Good morning, everyone. I hope you came away from yesterday energized and ready to dive into our last day. We have another fantastic keynote speaker and two panels. Before we begin, I want to thank the ICDS Symposium sponsors, our platinum sponsors, IBM, Dell, and AWS, silver sponsor VMware, and bronze sponsor Intel. Thank you. Over the past year, ICDS has been partnering with industry to support new research collaborations and explore new technologies. The challenges of the data deluge have been at the core driver of these collaborations. I'll give you a quick glimpse into one of our recent industry partnerships. This collaboration with IBM centers on expanding our expertise and capacity in artificial intelligence and machine learning. AIML was the theme of our 2019 symposium of several research initiatives supported by ICDS and of our annual Sea Grant program this year. In early 2019, ICDS put out a call for faculty interested in an initiative centered on artificial intelligence methodologies and applications. Around 20 faculty formed an AI faculty engagement team. In summer of 2019, several of this group, a few other faculty, and a couple of the ICDS team traveled to IBM's Yorktown facility in New York to learn more about the IBM research initiatives and hardware. As a result of the visit, a number of IBM Penn State teams are forming. Last year, if you were at our symposium, you may recall that IBM donated an AC922 server, which is the same hardware that powers two of the fastest supercomputers in the world, Summit and Sierra. IBM increased the value of having the AC92 server to Penn Staters by having one of their by having one of their developers provide support to transition research codes onto the AC922. Researchers using the local system are now well placed to scale up to working on either Summit and Sierra if their research suggests that. Okay, have you ever wondered how many neutrinos are causing ultra-sensitive impacts on an observatory buried deep under the Arctic ice? You know, that's one of the things I wake up worrying about. If you have, you should talk to Doug Cowan. Using deep learning algorithms on the new AC922 system, Doug has reported a significant increase in the number of neutrinos detected, although it's just into the double digits. We're very grateful for IBM's support. Now, ICDS has recently launched the ICDS Innovation Infrastructure, or iCubed. Now, iCubed is a platform for industry partners to work with faculty, giving faculty the opportunity to explore their new infrastructure offerings. The first system in iCubed is a Dell box with Intel Octane memory, so we thank them also for working and giving our faculty these opportunities. We look forward to partnering with these organizations on newer opportunities and to creating partnerships with other organizations and providing a place for Penn State and our industry partners to work together. The IBM AC922 illustrates how new advances can be made with the right cyber infrastructure. Well aware of this need, ICDS has continued to make advances with RAW. Remember, that's the new name of our HPC system. Last year, we added an on-premises cloud computing component to RAW. We call this our High Performance Research Cloud, or HPRC. I know there's a lot of acronyms. It's suitable for several types of research, but one of its biggest benefits is its low cost. It's less than half the price of our basic memory cores, enabling researchers to do more at less cost. So if you want to find out more about that, reach out to our RISE team, and I talked about them yesterday, and they can help you figure out what's the best option for you, whether it's the on-prem cloud or one of our existing options. Okay, after all of that, I have the privilege of introducing Dr. Nick Jones to you, Penn State's Executive Vice President and Provost. Now, involved in most university operations, Dr. Jones serves as Chief Budget Officer and Chief Academic Officer. He oversees the administration of Penn State's research and educational programs, and these support thousands of faculty members and nearly 100,000 students across all of Penn State's campuses. Nick's a Kiwi, which means a native of New Zealand, and he completed his undergrad in civil engineering at the University of Auckland. He then came to the US to earn his master's and PhD in civil engineering at Caltech. Since then, Dr. Jones has cultivated a substantial record in higher education leadership, serving in key roles at the University of Illinois and Johns Hopkins University before arriving at Penn State in 2013. During more than 7 years as our provost, Nick has emphasized the importance of data-driven strategic planning and cross-disciplinary collaborations that leverage Penn State's faculty expertise and our vast research enterprise. He believes strongly in the promise of discovery through research in the computational and data sciences and the many positive impacts that result from it. Indeed, it was with Nick's strong support that RAW came into being. I'm so pleased that the Provost could be with us this morning to say a few words. Please join me in welcoming Nick Jones, and I'm imagining you all clapping behind the Zoom screen.
Great. Well, thanks very much, Jenny, for that kind introduction, and good morning, everyone. It's nice to be here. On behalf of the entire university, I want to welcome you all to day 2 of this year's ICDS Virtual Symposium, and thank you all for participating in this unique event. Jenny, I'm assuming that you probably spent some time yesterday talking about the result of the All Blacks Wallabies rugby test this last weekend, so I won't go into the details of that here.
I can't imagine how that slipped my mind.
Right, how about that? Anyway, so I know it's a little odd, we're not meeting in person this year, but I think we've all gotten pretty good at these technologies like Zoom, and you all still have a great opportunity to engage with one another, share knowledge, and encourage interdisciplinary collaboration, all of which, even in a virtual world, remain vital to making an impact through research in your fields of expertise. I do also want to just pause for a moment to thank Jenny and everyone who's involved with our Institute for Computational and Data Sciences for their hard work to deliver this event virtually, as well as to continue other programs and initiatives that support transformative research across the university. ICDS is Penn State's computational research hub, and the Institute is more integral than ever before to our vast research enterprise, which I think, as many of you may know now, exceeds $1 billion in annual expenditures. As we all know, advances in high performance computing are enabling us to take big data and to make significant positive impacts in society, with hopefully many more to come. HPC and data science are now commonplace throughout academia and industry, with effects on almost every aspect of daily life, including energy, communications, medicine, infrastructure, finance, transportation, manufacturing, I guess I should add polling, and more. Data science is particularly well suited to tasks that are data intensive and require many complex computations to be executed quickly. Using HPC techniques, researchers like you all can perform tasks in only hours that previously could take weeks or even months to complete. This makes big data enormously useful in many areas of research, from the physical and life sciences, information sciences, and engineering, to studies in education, business, and the liberal arts, among others. At Penn State, we believe strongly in the power of computational research to create positive social impacts, and we are actively and broadly engaged accordingly. Last year, Penn State became part of a $4 million multi-institution NSF grant aimed at identifying innovative solutions for societal, scientific, and industry challenges through strategic data science partnerships. As part of the Northeast Big Data Innovation Hub, we're continuing to collaborate on big data projects that are too large and complex for an organization to manage alone. Vasant Honavar, Associate Director of the ICDS, is a principal investigator on this project. More recently, Penn State joined 14 other institutions in a national collaboration to turn data from hundreds of thousands of medical records from COVID-19 patients into effective treatments and predictive tools. The National COVID Cohort Collaborative, that's quite a mouthful on a Thursday morning, connects NIH-supported programs with US Department of Health and Human Services agencies and clinical organizations to support the analysis of electronic health records on a new secure database. The Penn State Clinical and Translational Science Institute led our effort to join the collaborative, which also involves the ICDS, revealing how important interdisciplinary endeavors are to data-driven innovation. Ultimately, big data provides real-time access to current and historical information from multiple sources and the ability to analyze it. In turn, big data drive critical decision-making in virtually any coordinated effort in our global society, from economic developments to humanitarian efforts. All of you want to make new discoveries or develop innovative products and services that serve the public good. And the so-called data deluge is creating both opportunities to seize and challenges to mitigate. This global pandemic has brought this into sharp focus. Thanks to the latest advancements in many fields, including computational data sciences, artificial intelligence and big data can help in handling the huge amount of information derived from public health surveillance, real-time epidemic outbreak monitoring, trend forecasting, and much more. Big data can provide a massive amount of information to scientists, epidemiologists, health workers, and others, helping them make informed decisions as we combat the pandemic. The data can be used to track the virus worldwide and forecast the impact of COVID-19 in a specific area or an entire population. Big data can facilitate analysis of disease transmission, movement, and health monitoring, and it can bolster research leading to the development of new treatments to fight COVID-19 and other diseases, as well as broader medical innovations. Of course, we know the actual and potential benefits of big data during these times. But to someone on the outside looking in, someone who is not deeply engaged in the critical work that you all do, it can raise concerns, in particular with regard to individual privacy. In the US, HIPAA, the Health Insurance Portability and Accountability Act, lays out rules regarding data use, including the delineation between research and active population health management and clinical quality improvement. Following privacy laws is essential, but that can be achieved while allowing clinicians to learn. The key is realizing the value of big data in battling COVID-19 and showing how the use and analysis of it supports the public good without infringing on individual privacy or creating other harms. One of the 5 thematic priorities in our university-wide strategic plan is enhancing health. In that plan, we assert that Penn State will be a leader in promoting quality of life through comprehensive approaches to improving personal and population health. This will be achieved in part through our commitment to and investment in relevant research and in the technology to support it. The COVID-19 pandemic has positioned Penn State to make a difference through implementation of the plan's priorities. One funded initiative in which Vasant and the ICDS are engaged is a digital collaboratory for precision health research, which aims to establish workflows to analyze disparate types of health data and a governance group to oversee and approve access to those data. Beyond the pandemic, big data and related research are advancing science in profoundly impactful ways. And we, I believe, are playing a significant role. Recently, researchers at Penn State and Columbia universities announced the creation of an artificial intelligence tool for detecting unfair discrimination, such as on the basis of race or gender. This tool can help organizations avoid becoming instruments of discrimination, barriers to equality, threats to social justice, and sources of unfairness. This symposium showcases our researchers' commitment to the excellence and importance of their work. It also provides a forum for those of you conducting computational research to discuss your work and to make interdisciplinary connections, ones that lead to solutions to the problems of our time, many of which we might not yet have even identified. There are so many to take on, and inevitably more will come. As Penn State's Chief Academic Officer, I'm proud that we are so invested in exploring and working with big data. Penn State is a recognized leader when it comes to innovation and its impact on society, and these efforts are certainly a big part of that. The opportunity to bring together a community of experts through events like this one is extremely powerful, especially now. I want to thank you again for being here and working together to make a difference. Please enjoy the remainder of the symposium, and thanks for the invitation to say a few words.
Thanks so much, Nick. That's fantastic. Okay.
Okay, I've got to go and think about neutrinos in the Antarctic because I woke up thinking about that this morning. So nice to see everybody, and have a great event.
Thanks. So now we want to move on to our keynote speaker for this morning, and I'll hand over to Vasant Honavar to introduce our keynote. Vasant is an Associate Director of ICDS and Professor Edward Fryermore Chair of Information Sciences and Technology of IST. Thanks, Vasant.
Good morning. It's my pleasure to introduce Dr. Chaitan Baru from University of California, San Diego, and the National Science Foundation. So he's at National Science Foundation as a senior science advisor for data science. Right now for NSF Convergence Accelerator. Before that, he was a senior science advisor for data science for 4 years. And he has accomplished a lot while he was at NSF, and he has left his imprint on a number of programs. He co-chaired the steering and working groups for the NSF Harnessing the Data Revolution big idea, which I think many of you have heard about. There's been multiple solicitations that have come out of it. He played a leadership role in the NSF Big Data program right after I left from that role a few years ago. And then he was instrumental in establishing a partnership between NSF and major public cloud providers like AWS, Google, Microsoft, Azure, and IBM to support big data research. And that's not all. He was instrumental in setting up the Data Sciences Core program and served as an advisor to the NSF regional big data hubs, innovation hubs, that one of which Penn State is part of, the Northeast Hub, and as well as the Triparts program, which has helped set up some data science institutes. He's by training, he's a computer scientist / data scientist, and he likes to work on translational and applied research problems. And he received his MA and PhD from University of Florida and BTech from the Indian Institute of Science. Without any further ado, I would like to welcome Chaitan to give his talk.
Thank you very much, Vasant. Let me share my presentation. Does that look okay to you all?
Yes.
Okay, great. One small correction, since that was right at the end, was on the So I did my undergrad at Indian Institute of Technology, not Indian Institute of Science.
Oh, did I misspeak? Sorry. I spent too much time with the
Right,
Institute of
so that
Science. It's fine.
fine. So thanks very much for inviting me to this. And I
Chaitan,
was, yes.
it's, I think it's on presenter view.
Oh, okay. That's what I was afraid of. So let me see if I can. Straight this way.
And I should have mentioned this initially, but this session is being recorded as was yesterday's.
How does this look? Hang on. Now. Is that better?
Yep.
Absolutely.
Okay. Right. So as I was saying, I've been looking forward to talking to you all. Actually, I think this was originally scheduled for earlier in the year. And I remember this was going to be a trip I was about to make to Penn State on my way back to San Diego from DC, and everything shut down. And so here we are. I'm going to talk to you, well, as first I'll give you a little bit of a landscape and some of the activities that Vasant actually mentioned, just to show you sort of the timeline of how things have been progressing at NSF, and then talk to you more about this brand new program, which is an exciting new program at NSF, the Convergence Accelerator. It's very interesting to and encouraging to see that you have industry support for this center, because we are talking about partnerships with all sorts of sectors, including industry, and through the Convergence Accelerator, producing outcomes that are impactful to society. I also want to quickly mention, because it's not in my talk, I heard a mention that Professor Jones made about your COVID cohort. And we have funded something called the COVID Information Commons, which is bringing together information of all the COVID-related rapid awards that NSF has made, which are over about 700 projects. And at some point, maybe I'll send email to Vasant or someone. It'll be interesting for me to find out what's going on there. Okay. Excuse me. So first, setting up the context and the timeline, I think we all in this field realize that things have been moving very fast and they continue to move. The big data program, from an NSF point of view, the big data program at the federal level was created in the previous administration back in 2012. Established a program at NSF, and a few years after that, shortly after I got to NSF, the previous round, which was in 2014, we started talking about this big set of big ideas, and harnessing the data revolution was one of them, which is really about data science. And before you know it, we were into machine learning and AI. And of course, as you may all have heard, NSF just announced a set of AI institutes, 7 in the first round. And then there's a solicitation out on the street for the next round of institutes. And I think that's going to continue for a while. We have a new director at NSF, Dr. Punch, as we call him, and he's very excited about these initiatives. The Big Data Federal Initiative created the Big Data program at NSF that Vasant was very much involved in getting started. And that went from 2012 to basically sunset in 2018. And as was mentioned, one of the things we did there was, for the first time, that NSF had a relationship with the public cloud providers, a couple of whom are your sponsors here, AWS and IBM. And one of the people who we worked with there was actually Sanjay Pardee, who was a speaker yesterday at your meeting. But we also have Microsoft Azure and Google as part of that. So that was a very important sort of start of a relationship. And then more things are happening. You might have heard about the Cloud Access Program, which has been funded as a project called Cloud Bank, whose job is to make it easier for academic research projects to access the cloud. And actually, in terms of timing, the tripods program, the idea for tripods actually preceded the HDR big idea, though now tripods is really part of HDR. And it started because as we were doing this big data, and big data in a way is really the genesis of data science, because if you're familiar with the program, it had components of multidisciplinary research, it had components of foundational ideas, and also systems building. So it had a bit of everything in one program. And the idea at that time was, so what's all this big data about? Is there any theory behind it? Can we say something in a more principled way about putting data together to get results? And that's how tripods was born. But soon after that, as in the slide, the HDR big idea came around because NSF at that time was strategizing on what are the big ideas for the future, and data was clearly one of them. So the HDR big idea, when it was first introduced back in November of 2016, had these components of foundations, natural set of things, right? Foundations, algorithms, and systems, the the data cyber infrastructure to support all that, and then applications of it in science and engineering, and then what's the agenda for education and workforce. So I'll say a little bit about all the programs that fall under those categories. So as I mentioned, even though Tripod started earlier, so if you look at the timing, April 2016 is when we ran that workshop called Theoretical Foundations of Data Science. And at that time, the concept was we really need to bring the theoretical aspects of computer science along with math and stats to start thinking about the foundations and the principles of data science, which led to the tripods. The idea at that time was that we would like to have a couple of centers in the country around this notion. And we thought, okay, let's do this as a phase one initially, fund more projects and see how they can get together and form collaborations. One of the things that came out of that workshop, and I think a lot of these will be familiar issues to a group like ICDS, we literally invited a third of each to the workshop, computer science, math, and stats. And first thing they identified is, we are all generally talking about the same issues, but we all use different language. And so the first thing we need to do is get on the same page about what do we mean when we say, X, Y, or Z. So we decided to have a phase one where we thought, okay, let's see how people do come together. And then we would do a phase two, which is the centers, and all of that has happened. That phase one was September 2016, phase two was September 2019. In the meanwhile, again, as you all would be familiar, other directorates at NSF, because CS Math and Stats basically touches two directorates, it's the SciSce and MPS directorate, but there are a lot of other directorates who are also saying that, well, we also want to play a role in the principles, not just in the applications, right? Because some of the foundational and principles-based approaches may be influenced by what we bring from our domains. And nowadays, of course, even things like ethics, we think about that. So that's how Tripods plus X was started, which was adding, in some sense, X being the domain to Tripods. So that's the foundation's history. Some of the original thinking in the algorithms and systems was back in 2015 or so, we started thinking about this idea of open knowledge networks. And not just out of the blue, we actually had a workshop for thinking about strategy for big data. What should be the federal strategy? And folks from industry, in particular, Andrew Moore, who had just come back from Google and was at CMU, and now he's back at Google as the head of AI for Google, had given a great keynote in which he pointed out to several things where work needed to be done. In some cases, that industry was ahead. If you remember, back in the day when all this big data stuff started, it was industry leading the charge, including in cloud computing, and we were all trying to catch up from the academic side. And one of the things he talked about was open knowledge networks and how this was essential technology and basically its infrastructure. And so anyway, we had workshops on that back in October. Another idea was sharing of data and especially sharing of models. So what we mean by models here, initially we meant data intensive models, so things that come out of machine learning, et cetera. So if you've already created a model, could somebody else use it? How far could you go in using it on some completely different data set? before, it's not really usable, or maybe it had to be retrained. So all of these issues, and also how do I know, is there enough metadata? Is there enough contextual information that allows me to reuse? So all of these were also issues, and we were thinking of it as the so-called model commons idea. We even ran a workshop at CKDD on that, and that happened in August of 2018. I'll come back to some of these later. On the cyber infrastructure side, some of you may be familiar with the Office of Cyber Infrastructure had these programs on software and data. One was called DIBS for data, and there was one just on software. And in 2018 was the first time they basically combined the two and said, it doesn't make sense to sort of artificially separate data and software. And so you have the first time the solicitation that talks about data and software together. Also around that time, we had this notion that part of the cyber infrastructure, just as you all have machines that were mentioned earlier, is also infrastructure for sharing data. And so this notion of could we have a storage network which is on campuses, which may, in fact, the requirement was that they should connect to cloud networks. But there are many reasons why you want to have, you might actually want to have an academic network that's actually separate from the, but connected to the cloud. So there was this notion of open storage network, and actually the big data hubs were involved with it. And this map shows you where some of the nodes are, and those folks are still trying to keep that going and working on that idea. Then we come to the applications side of it, right? The so-called applications. And this has been conceived within the HDR big data idea as the institute. So these are the HDR institutes for data intensive research in science and engineering. You may have seen solicitations on this so-called DERSI thing, both for ideas labs and so-called frameworks. I think these ideas labs are important, and I assume that you would be doing similar things on your own campus to bring multiple domains together, again, with data science and technology folks, with science folks, exactly for the reason that you all want to get on the same page, understand each other's language, and really know what problem you're trying to solve. And that was the notion of Ideas Lab. Can we bring the stats and computer science people who are contributing the technical things along with the applications folks, and of course the social scientists, to conceive of what an institute might do. So that was phase one, and I guess the phase two is forthcoming. On the education and workforce development side, and by the way, I should say that these are not the only programs in any of these areas. There are, as you know, NSF is pretty wide and diverse. Sometimes directorates have their own programs that resonate with these themes. And I'm only giving you more of a perspective, maybe coming from the HDR side of things. On the education and workforce, NSF research traineeship program is a sort of foundation-wide program, and it has had focus on data science before. And as was mentioned, we started this idea of a data science core, which the idea there basically was, I think you can now think of it as experiential learning, that in the case of data, you don't really learn about data until you actually use real data, until you understand the sort of messiness of real data. And one of the ideas was, so it's not just about, you could bring real data sets into the classroom, which helps rather than some fake data. I'm a database guy. In the old days, everybody had the wine database, right? Okay, but how many of us run vineyards? But on the other hand, if you send students into the situations, so those of us who work with data, you know that when you actually see what's going on the ground with data, things can be a lot more shocking, and you actually get a much more deep understanding of what's happening. So that was the idea of data science core, and hopefully there are more solicitations coming out for that one. So now I'm going to switch and talk about, it's a natural transition when we talk about in the area of data, that at the end of the day, the data is just a means, it's a tool for solving some problem, whether it's discovery science or some societal problem, whether it's COVID predictions or contact tracing, whatever it is. There is a problem you want to solve. And so you want to transition from just doing research into having impact. And that's what I'm going to talk about for the rest of the presentation, transitioning research to practice. And I'm going to tell you about this new program, and it's not just like an SBR or commercialization type idea, and those continue to go on. So commercialization idea is more like, well, I did something, created something cool out of my research project. I think there's a company around it, and I want to go make a company out of it, right? I have some patents and so on. Of course, once you form a company, we all know, the company itself may evolve and so on. But the initial idea simply is to take the idea you had in the lab and commercialize it. Here we are talking about something a little different. First, we want to identify problems that are viewed as sort of societal scale problems that require convergence. And by convergence, we mean deep multidisciplinary interactions, which ICDS would be very familiar with, but also multiple partnerships, which also you seem to be familiar with. And the partnerships can be between academia, industry, government, nonprofit, any other sectors. And actually that partnership is a requirement, as I'll say, because that's where you will get the notion of what is the actual thing you're doing for impact. The program, and that's the convergence part of the convergence accelerator. The acceleration part is that we want to do this quickly. So you'll see that the program is basically end-to-end, a 3-year program with deliverables. And deliverables can be a wide variety of things. But then there's a question of whom are you delivering this for? So identifying and understanding who your users are is also part of this program. And in fact, we put awardees through a curriculum that they have to go through to learn some of these things, which I'll say more about. So that brings us to this new program, which sits under the Office of Director. So it's across all of NSF, called the Convergence Accelerator, whose mission is basically speed the transition of this multidisciplinary convergence research into practice for problems that are considered to be larger scale problems, not just what you may happen to be doing in your lab and out of curiosity driven research. The vision is that you want to capitalize on these new concepts to provide leadership and also leading to maybe education and workforce development out of that. The notion of this is some of the kind of problems that we want to tackle are the ones that you couldn't just do by one domain, just computer scientists doing it or neuroscientists doing it, but it actually requires a real multidisciplinary team of folks working together. So we want to leverage science across all fields of NSF, and it is the notion of transitioning from research to practice. So it's not, on the one hand, it's not about doing too much foundational or original research. You expect to already have a body of research. On the other hand, it's also about identifying what already exists and saying, okay, now we are ready to transition this into the next stage. In terms of how it's being done, it's a new structure. And as I'll describe in the next set of slides, we say that this is not your mother's NSF, right? This is completely different from the rest of NSF, which I think we all in the group find very exciting. I certainly find it exciting to come back to NSF and work on this. So therefore, the characteristics of projects here are they are use-inspired. They have clear goals and milestones and hopefully high impact deliverables. They leverage multidisciplinary teams. They should be working on larger scale issues. And they require diverse partnerships with industry, nonprofit, academia, etc. Increasingly, we are fine with anyone leading these projects. You can imagine in the early days, academia, so PIs tend to come from academia, but it's not a requirement. The PI could come from industry or a nonprofit and so on. And we certainly have a couple of funded projects where we have actually in one case, it's a nonprofit company is the PI. In terms of management, it's proactively managed by us. So as I'll describe, NSF actually defines these so-called tracks, which are the topics. And proposals have to respond to those topics, which are defined by these tracks. And all the projects within a track are of course trying to solve that problem, but we also expect them to cooperate and not duplicate. So it's, again, that way it's different from a typical NSF program where you just fund a bunch of essentially independent projects. They could be competing with each other on this, developing the same algorithm or whatever for solving a particular problem. Here we are going to say, if some other team is doing something, you should be looking to leverage it and don't duplicate the stuff. So there's the notion of a track cooperation. Okay. The other thing that's unique is that we actually provide a very intensive education program for the teams in phase 1 as well in phase 2. And they have to actually attend classes and take these classes and do the homeworks around these notions of design thinking, human-centered design, team science, and customer discovery. And the evaluation, as I said, is based on how have you helped the mission of this track. We don't particularly care about publications and student production. In fact, we say if that's the only thing that came out of it, then that would be a failed project because we are looking for deliverables. So I'll spend just a little bit of time on this very busy slide because it explains the whole program, okay? So the way it goes is it's a 3-step process. First, there is the so-called ideation process, generating the ideas, which will end up as tracks. And I'll mention at the end that right now is an opportunity for you to help define the tracks for 2022, because the 2021 workshops are going on right now, but we have also announced the ideation process for 2022. So through a process of running workshops, talking to the community, including talking to our colleagues at NSF, we fund a set of workshops which we hope will generate the ideas from which we can select the tracks. And then in the middle boxes, once we choose the set of topics for the tracks, we do the solicitation, and then there's a selection process based on have you demonstrated the readiness of this idea to go to a fast acceleration mode, multidisciplinary team, partnerships, etc., etc. Phase 1 is potentially up to 750K in 9 months, and it's just for planning. So what I mean by just planning is, this is where you really shake out your group, make sure you have the right team, make sure you've really identified who your users are, that you're producing the things that your users want. Make sure that your team is able to work together. Maybe you'll do a prototype, etc. At the end of phase 1, only phase 1 teams can apply for a phase 2. And there's a 2-step process there. You write a proposal and you get reviewed in the typical NSF way, but you also do a stand-up pitch. You stand up in front of a committee and make a pitch, so in front of a panel. And that panel is usually, it will be filled with non-academic. So it's usually people from venture capital, industry, maybe government and other areas. And so they're listening to your pitch and they're doing more of a sort of a venture capital industry style evaluation of your project, in particularly looking for, do you have something that's actually deliverable, feasible, etc., along with the standard NSF review of the proposal. And then comes the second phase where you can receive funding up to 5 million for 24 months. One of the things we are learning about this is a brand new program, by the way. So we are very open to say, even we at NSF are learning about how to do this. And we really, really encourage teams to build these budgets bottom up. As you all know, I mean, we've been starved with money for so long in the NSF community that usually when you see a budget number, you do top down, right? You just say, okay, how do I spend $5 million? Here we are trying to say, no, tell us how you've come up to this 5 million. Anyway, so it's up to 5 million over 2 years to get it done, right? So you got to move quickly. If you want to hire full-time programmers, go for it. If you need to buy some kind of equipment, you should. So we don't want to have any constraints in the delivery process. And this kind of funding also, we hope, allows industry to play, because we might have to pay folks a little bit more if they're coming from some sectors and so on. And then the question will be, how do we evaluate this at the end of the day? Some of these are open questions even to us. And how do we keep the sustenance or sustainability of what has been done? So talking about where we are today, in 2019, we started this. And so here's where we come back to some things I mentioned before. In the very first year, we didn't have this ideation process. We went around the NSF, I won't go into the details, but we looked for existing ideas that we already had, one of which was the Open Knowledge Network, and the other one was AI and future of work. And as you know, future of work is one of the big ideas at NSF. So the track ideas came out of the big ideas that NSF already had. But starting from then onwards, we have been running these workshops. So the current cohort that has just started that's the 2020 cohort. The two tracks are in quantum computing, and as I'll mention, Penn State is one of the awardees there. And another one on track D, which is enabling AI innovation via data and model sharing. And that resonates a little bit with the model commons idea I mentioned before. So this diagram actually shows you where we are. There's a lot going on for us in our group. The top line is where we started in 2019, track A and B. They finished their phase 1 and the phase 2 has just started. So we've gone through all of that review, etc. process for them. We have selected 5 projects there, each receiving about 5 million, and they're off and running for phase 2. We already did the ideation process last year for the next round. And that's the phase 1 that has just started. So that's the 2020 cohort, track C and D. So 9 months from now, they will be into their competition for phase 2. Right now, as we speak, in the last few weeks and into the next week or so, we are running workshops for next year's tracks, okay? But as you can see from this that we are trying to pull the timeline ahead a little bit for various reasons. An important reason being, we want phase 1, feedback we received from the community was that phase 1 should ideally start at the beginning of summer because, and this is in the old days before COVID and so on, but summer is where faculty have a lot of time to work on this thing. And actually, now that I think about it, with things slipping in academia, I wonder if summer is actually going to be busy for faculty this time around. We'll see. So anyway, we've been trying to pull this forward a little bit, which is why some things are happening in a hurry. So even as we are running workshops right now for next year, we have just announced this DCL, Dear Colleague Letter, which is, if you want to search for NSF 21-012, that is asking for ideas for 2022. So this is your opportunity to participate in that process. I'll just quickly mention what some of the projects are that are ongoing. So this is track A, as I mentioned, which is in phase 2. There's one on urban flooding. And I noticed that there is an institute at Penn State that's about earth science and hazards. And so one thing we do in this program as part of our very hands-on engagement, we meet regularly with the teams, both to ensure that they're making progress on the project management side, but we also meet with them to talk about technical things, to see if we can help them or they can leverage things or connect them to industry and so on and so forth. So we are happy to connect these teams to other work going on in the community, for example. So if there's something already happening and they could just use an existing data set or use an existing service, more power to them. So part of why I'm mentioning these to this audience is, if anything resonates here, you should feel free to contact us and say, hey, we're doing something in that, can we go talk to these folks? The other one is on biomedical knowledge network. So the first one is PI is Lilith Yegisarian from Cincinnati. The second one is the PI Sergio Baranzini from UCSF. There's one on taking court records and making a knowledge network, a very interesting project about how to do analysis of what's happened in court cases. Luis Amaral from Northwestern is the PI for that. There's one that's looking at embedding geospatial information in knowledge graphs, and that's Krzysztof Janowicz from Santa Barbara. And another one that's talking about actually building programming environments that are that make it easier for you to program with knowledge graphs and knowledge networks, and that's Mike Caffarella from Michigan. So these are the ongoing projects in phase 2 for track A, and this is for track B. Those are 4 boxes you see there. So there are 4 projects in track B. One is called the competent, and this diagram is showing you that, the kind of work they're doing. So there is the whole area of matching workers with work. So looking at what your background is, looking at job descriptions and trying to do a matching function. There's a topic of training and educating and giving recommendations on that. And then there's sort of skills development and curriculum development. We had, let's see, something like 22 projects in phase 1, and this figure would have been filled with all those 22 projects. And what I'm showing you is only the 4 that made it into phase 2. So one is Competency Catalyst, Robbie Robson from EduWorks, and that's an example of a PI from a non-academic. The other one is on dealing with sort of the autistic population, it's called neurodiverse employment. That there are a lot of folks who have a lot of good skills there, but they have other shortcomings that sometimes that usually come in their way of getting a job. And so dealing with all of those issues, which is a very interesting problem. The other one is about using robotics-based approaches to help emergency responders. So the neurodiverse one is Nilanjan Sarkar from Vanderbilt is the PI. And then the robotics for next-gen responders is Mehta from Texas A&M. And the last one is about using generating AR, VR settings for training in the manufacturing section. And that's Ramani from Purdue. Okay. Now, jumping to the current year, C&D, we have funded 11 in phase 1 for track C. And this is about quantum technologies, and you can see the topics there: quantum sensing, simulators, interconnects, architecture, workforce. By the way, IBM is a pretty big partner in many of these projects, and they have been very eager and forward in terms of helping projects and working with us. There are some other companies involved as well, and many of these projects actually have folks from industry in them. I just have a feeling that there's somebody from Intel as well, but there is industry presence in these projects. And in track D, we have 18 projects, which are both about data and model sharing. So looking at curation and sharing of open and as well as sensitive protected information. So this doesn't have to be just data that's completely open. There are many cases where people want to share information that has privacy or other sensitive aspects to it, but a group of people could still share it. And we want people to address what are the issues of building systems for those kinds of situations. And of course, dealing with the ethics, fairness, and bias issues in that. Okay. So this is just a landscape of all the projects in track C, the institutions where they're based. So that's 11 projects. And as I mentioned, I think this is Professor Swarup Ghosh and a team from Penn State. Actually, it's the only project in this cohort that's really combining quantum computing with AI. So it's interesting. In a way, it's spanning both C and D. It's the only project that's doing this. All the others are pretty hardcore quantum technology things. And here's the set of projects that are for track D. And I just listed them here only just to give you a very quick sense of what topic areas they're in. So this is PI and PI institution in the first 2 columns, but the last column, and I tried to use some shading of colors to show similarity. We have a few projects looking at medical information. In fact, a couple of them actually talking about building federated learning systems. So if data are so sensitive and private that you can't move them around, but you still want to do machine learning in a distributed setup, that's that. There's one on developing a model exchange framework in a language in neuroscience. There's an interesting one that Davis and Iowa State involved on veterinary data for the sort of pork industry. One looking at facial expressions for American Sign Language and helping there. Biome data, and Microsoft is a big part of that, collecting all sorts of data about ecological information, which actually can lead to things like making predictions on mosquito populations and disease spread and so on. A couple of projects related to water. There's a groundwater project and also a water system project. And as you heard before, Track A actually has a project on urban flooding. So there's a bunch of, there's sort of a collection of water related things. One on wildfires, civil infrastructure monitoring, one on developing models in a built environment, microgrids, cybersecurity, and then chemistry and polymer data enabling meta-analysis across large existing heterogeneous data sets, and a couple that are a little bit more what we like to think of as horizontals, in the sense that they are developing capabilities that anyone could use. They still need to have use cases from some domain, but they are building, in one case, a platform for managing AI models and data sets through a more of a computer science approach of a query search engine and a language. And another one is building what they call a data hypervisor, which is, how do you share securely, sensitive data? What kind of platform would you build for that? So that gives you a sense of the kinds of projects. Now, I don't need to spend too much time on I already mentioned some of these. So phase one is accelerated. There's an innovation curriculum that you have to go through. Also, one thing I didn't mention is every team is provided a coach, okay? And the coaches meet regularly with them. And these coaches are all folks who have had experience with startup companies and venture capital one way or the other. So one thing I will say is there's a lot of excitement among the teams in this approach, in this program. I think folks are finding this tremendously interesting. It's, like I said, it's very different from anything that NSF has done before. And one of the things we are hoping, I certainly personally believe in this, that doing more, that all of us in our community doing more towards impact and transitioning to practice and demonstrating the value of what we do, maybe especially at a time when there seems to be growing skepticism of what does science get me and so on, I think is important. And hopefully these kinds of approaches actually go back and influence what people are doing on campuses. That's the fond hope. Okay. Right. And as I said, so once phase one is done, and if you make it through the pitch competition and so on, then you get into this accelerated 2-year phase, and you're getting more into a product mindset. You continue to have coaching. In fact, as I said, we are 2019 when we started it, we call it the pilot year. So we are definitely in the pilot phase for phase two. First time we are ever doing this. We already learned a lot in phase one, what was good and what mistakes we made, trying to fix it now, and we continue to fix it for the future. But one thing that all the teams from phase one told us was they just loved having this coach. The coaches were ultra useful for them. So the coaches continue. In fact, they themselves ask, can we have our coach, follow us into phase two? So that happens. So I just want to end with coming back to the ideation process for this year. And I mentioned this already, there is the DCL out. Responses are due very quickly, but this is it's not a huge survey. The process basically here is for you to go there and fill out the survey, answer the questions, and identify what might be tracks. We will evaluate those, and then we will fund a bunch of workshops as the follow on of that. And then the workshops will create reports. So this year, right now, we funded, I think, 12 workshops across a very broad range of ideas, everything from ocean sciences, plastic, the life cycle of plastics, to privacy and pandemics, to inauthentic behavior in online systems, the whole range of things. And out of that will come reports that we will then use to determine what the tracks will be. So that brings me to the end of my talk. I'm happy to take any questions. I'm trying to see what the time is. I think we have some time.
Thank you, Chaitan, for that talk. So I'm looking to see, we're monitoring the questions here. So while we're waiting for people to get their questions ready, maybe I'll ask you, and so you've spent time at NSF, and maybe you have some advice for faculty and others here about getting engaged with NSF in that sort of a setting. I certainly found it very useful. It opened my eyes to a number of things, and so maybe your thoughts.
Yeah, I mean, as I'm sure you know, Vasant, it always surprises me how little people talk to NSF program officers. These program officers are not scary people, right? And actually, they want to talk to the community. So even to this day, I get very senior people calling me and saying, I have this idea for such and such solicitation that's out there, and what do you think? And I say, look, the solicitation lists who the program officers are. Just pick up the phone and call them, because they'll tell you if there's a crazy idea or if there's an idea that they like. I think you should do more of it, because they are eager. I think NSF folks are, I mean, as you know, I mean, NSF actually is a very nice place to work, because the people are very nice. It's a fabulous environment. And they do want to help you. I mean, it seems scary sometimes that, oh, they're going to judge my idea. And the one problem is, because we could use much more funding, we have much less than what we really should have. The selection rates are so low that people are like really scared, right? If I just said this, maybe they'll reject my proposal. I wouldn't have that mindset. I would say, hey, let me come and talk to you about my idea and tell me. I've certainly done that more in the previous role. In this role, things have been moving so quickly, and people's heads are spinning, I think, about what is this program and what do we do. But even here, in any case, in the previous role, many people would come that I've certainly talked to at NSF, who would come through in the good old days when you could actually visit NSF, and you don't even need to do that. Now it's even easier. Just set up a Zoom call and you can do it. I was able to give people a lot of guidance that hopefully help them, either one way or the other. Yeah, do it. There's a great idea, or that may not be a good fit. So I think I would encourage, in addition to, of course, going to NSF and doing a stint. But as you know, that's been hard in computer science, because computer science departments are so overwhelmed with teaching. So I've certainly seen people where the department chair in some weak moment agreed to send somebody to NSF and then regrets it and says, you got to come back.
So there is a question from Jenni. I think she's asking, are there any overarching themes for 2022 emerging from unsuccessful but competitive proposals in the first 2 years?
That's a great question. You should look at the Dear Colleague letter text. Like I said, everything is changing all the time. So it was, it was big data, and then it's data science. Now it's AI, ML. The latest thing that has come from the administration is this notion of industries of the future. It's called IoTF. Okay. And let me see if I can tell you all. There are 5. So quantum computing is one. Of course, AI, machine learning is another. 5G, biotech, and smart manufacturing. So not surprising, right? I mean, the 5 are not surprising. So if you think in terms of quantum, we already have a track this year. AI is such a broad area, but you could, in fact, 3 out of the 4 tracks have AI in them right now among A, B, C, D. But that doesn't mean you couldn't have another AI one, because just AI is it's a very broad notion. But there's things like 5. So advanced communications could be one. Smart manufacturing. So we are actually running. And another thing to do is go look at. So if you just do a Google search on NSF Convergence Accelerator, more or less the first hit you will get is our website. So go look at that, and we've listed all the 12 workshops that are going on right now. So one good thought is you don't want to repeat those topics because those workshops have just run. So you want to pick something that's different from those, but might still resonate with the IoTF areas. So this, I mentioned the plastics. There's one about, I forget what it's called, but it's the end-to-end life cycle of materials and products. So how do you produce things so you don't create too much pollution, that kind of idea. And plastics is the idea there. So that's one way to look at, and it's a good question also because we have been thinking that if there are some good if there are more than 2 good ideas that come out this year, we might bank some for the future, maybe the next year or the year after. Of course, we have to see how the landscape changes, but that shouldn't make you shy. I mean, I think if you have a great idea, you should still go for it and propose it. So, yeah. The one thing I will say, and actually we just had a conversation 2 days ago with one of our phase 1 teams that didn't make it to phase 2, about the involvement and importance of social science. So the more, I'm a computer scientist, but the more who's at a supercomputer center, but the more I think about it, social science is extremely important for us. Convergence Accelerator is talking about societal impact. Well, what does it mean, right? It's impact on people. Well, so there are all sorts of behavioral stuff, maybe economic models and theories, but also other social and I would say even humanities that are essential to understanding whether something can have an impact or not, or why is it having an impact or not having an impact, whether it's fake news or plastics or whatever it is. However, what we have found, I want to be careful. By the way, most of what I said today is my own views, so don't take it as official NSF line. I think at least in some corners of social science, this notion of doing something pragmatic in 2 years may be a very new idea. But at the same time, we need them, right? I don't think we should be producing some of these technologies without understanding some of the social aspects. So there's a challenge here, not just for us. So by the way, we are thinking of running a workshop yeah, where we would like to invite some social scientists, including senior people like deans and so on, to say, hey, how do we get your community more engaged? Because what we are hearing from the faculty is engaging in this kind of thing is viewed as very weird in the social science circles, because you're not writing a book, you're not creating a new theory and those kinds of things. Yet at the same time, so it's pragmatics in social science. That's a challenge. I don't know how, the same thing goes with ethics, right? Like, Vasant, I mean, folks like Lisa Gatur, who's at UC Santa Cruz, has given me stories of how if a computer scientist stands up on campus, and we have it in our own campus here, and says, oh, I'm looking at fairness and bias, you might get an explosion from the other side of campus in the humanities department saying, what are you guys doing about ethics? That belongs to us in the humanities. Well, but it's an issue. I mean, it's happening. So we need the help. So how do you make it happen is a challenge.
Okay, so I'm not seeing any more questions. So maybe if there are any, then maybe you can reach out to the speaker directly. So at this point, I would just like to thank Chaitan for taking the time. It's very early where he is in San Diego. So he's had a really early morning. So thank you, Chaitan.
All right, thanks for the invitation.
Let me join with my thanks, Chaitan. Could you unshare your screen?
Yes.
So once again, thanks for giving us a great context for, for creation of interdisciplinary AI initiatives. I think that Penn State is really well suited in this. You already saw the quantum AI phase 1 that's come through, but we have such a long tradition of interdisciplinary science and quantitative interdisciplinary research that I think you can expect more competitive things coming from you. Coming from us. So thank you again.
All right, thank you.
Now let me share this. There we go. So now I want to highlight this afternoon session. Now we'll see you back in Zoomlandia around noon for the final 2 panels. And let me just say, Anne McKenna has convened the panel Social Engineering with Data, Disinformation and Destabilization of the Geopolitical Order. And we just found out that Governor Tom Ridge will be joining that one. And Alexandra or Sesha Slavkovic has convened another terrific panel on data, genetics and DNA value, ethics and risks. So once again, you can find links to the panel sessions and more detail on our ICDS Symposium webpage. I know that you'll find these panels to be thought-provoking, whichever one you join. But since this is the last time we'll all be sharing a single Zoom location, I wanted to take time to thank those who've been instrumental to the success of the symposium. So my thanks to Sesha and Anne for today's panels, and to Asad Azemi and Sounda Kumara for the panels yesterday. The 4 conveners have taken us across a broad landscape mapping the data deluge. And of course, many thanks to our 2 keynote speakers, Shantanu Jha and today Chaitan Baru, for their shared wisdom. And the symposium simply wouldn't have been possible without the program committee, who developed the fantastic program that you've seen, including the panels this afternoon. Don't forget them. And I also want to thank the talented and determined ICDS team members whose efforts ensured that this exciting program went off without a hitch. And that was essential to the success of this event. I don't think any of you saw anything happen that was untoward, and my deep thanks to them all for pulling that off. And thank you all for being part of the symposium. Enjoy the afternoon session and please stay in touch. So thanks again.